Flack math! Give me some math and I'll give you some flack. Flack math!
Okay,
My mom calls me special needs.
we are going to talk about triangle congruence again. We already did one. There was one postulate that we learned that could prove two triangles are congruent. Do you remember what that was called?
Like postulate 7, right?
It was postulate something.
Postulate 11.
Is it postulate?
9.
Don't give me a
13,
number.
12?
Yeah, I think it was like 13 or something weird like that.
Yes.
But
11. I was closer.
what do you need to prove that two triangles are congruent?
You need the angles. You need the angles of the
Pythagorean?
So that's not a postulate. That's like
That's a theorem.
you could say two triangles are congruent if all 6 of their parts are congruent. Okay? But this postulate says, oh, actually all you need is boom, boom, boom. What is it? You remember? If you can prove that congruent, then
A plus B is congruent to B plus C.
no. If you can prove that just the sides are congruent, then it's congruent. That was the
I was gonna
SSS
say that.
postulate. This is,
Oh yeah, we just figured it out.
Oh, the transitive property. Right?
that's your go-to for, that's your answer for everything. So we are going to prove that if two sides of one triangle and their included angle, the angle in between the two sides are congruent to another triangle with two sides and an angle congruent to those parts, then we can prove that those two triangles are congruent. Okay? So here is what I'm going to say. So first of all, this is called the included side. So this is a side. This is the included angle. It's the angle in between the two sides. So this is called the side angle side theorem or postulate. So if two sides and their included angle of one triangle are congruent to two sides and their included angle of another triangle, then the two triangles are congruent. Okay? So this is how I would spell it out. So this is the SAS.
Sas?
Yep, triangle congruence postulate. If
Well, I guess I have one.
two sides and included
Angle of one triangle are congruent to and sides included angle of another triangle. Triangles are
Thank you, Tristan. I can't tell you how helpful that was, because then I didn't have to keep looking, and
Oh, you're welcome.
so that's
I'm just
great.
going off my
Hey,
sister's
did you start
notes.
your video?
Oh, seriously? Nice. What's that?
Did you start your video?
Yes, thank you for reminding me.
My sister quit geometry 2 days.
Okay, so let me just give you some examples. This is what it looks like. If I have a triangle here and a triangle here, and if I have this side and this is congruent to this side is congruent to this side, and then if I can say that this angle is congruent to that angle, then those two triangles are congruent. Okay? So see how it's got to be the angle in between the two sides. Okay? Here's a good reminder of what you're looking for. It will never spell out a naughty word. Okay? So it's not enough to have an angle over here. So there's no such thing as an ASS postulate. Okay?
Dang it.
But that's a good way to remember it, right? You're not supposed to say ASS. If you're
It's
talking
just a
about
donkey.
donkeys.
No, I just remember.
Is that what
Sas
you think about when you say that word?
Always. 'cause
17
in
times a
Shrek-
day, Tori?
No, because in Shrek, Shrek calls Donkey a jackass, but he's a donkey, so it's fine.
I have to I have to get my. I'm not gonna say it.
I think
Okay.
about that a lot.
All right, but anyway, that's a good way to remember this. The angle has to be in between. So there is another postulate called AAS, and that's an okay postulate. We'll talk about that later. But there's no postulate called ASS. Like when I was your age, I'm like, oh my gosh, we're gonna learn that tomorrow, and I'm gonna have to laugh, and I'm gonna giggle. I'm gonna get in trouble.
Like intersection?
So I'm gonna laugh because he's gonna say ASS. No, he never did. I was so disappointed. I just wanted that. I know.
I'll
That was
say it.
You
weird.
wanted to get in trouble?
I just wanted to see that word on the chalkboard. Yes, we had chalkboards back then. Not
How
like-
could you sing the sound?
That's just bad. I know. I was immature.
I was gonna say,
Okay, but I was already struggling with geometry, and I was getting like a C.
Wait, so
Oh, wow,
if
how
you were
terrible.
struggling with geometry, how were you struggling with like trigonometry?
Oh no, I didn't struggle with anything else except geometry.
That's
Because
why.
it's like making you dumber.
No.
Because you're unlearning everything you learned.
Well, you're just analyzing everything you learned. And I don't like to analyze stuff, I just like to do stuff.
I don't like to do.
And that was filmed. That was recorded. Yes, Tristan.
Do you guys have markers back?
Yes, but we didn't draw on boards like this. We had chalkboards.
When did they
I
create
used to have a
whiteboards then?
chalkboard in my house.
Yeah.
I thought they always had whiteboards.
No,
Okay.
like they
Since
came
like
around
the
in like the
1400s.
90s.
So here's what I want you to do. I want you to find the value of x that makes the triangles congruent. So if I said that this equals 6x minus 27 degrees, and this is 4x plus 7 degrees. So if these triangles are congruent, then that means these two have to be the same, right? How did I put a degree symbol over there? So how do you solve for x? How do you solve for x? Yeah, just set them equal to each other. 6x minus 27 equals 4x plus 7. How do you solve this equation?
Sorry, he dropped his pen and I was trying to give it back to him. Sorry.
You dropped
Scared
it
me.
all the way over there.
No, he dropped it by Maddie's foot and she handed it to
Okay.
me and I handed it to
Yeah,
him.
I threw it all the way over Maddie.
Okay. How do you solve this equation? You have variables on both sides. Get rid of the smaller one. Minus 4x. Minus 4x. We're just doing some algebra now. Sorry, Tori.
I don't associate with this.
Be what, 17?
Okay. Add 27 to both sides, right? You get 34.
Plus 7 is 30 something.
34. So 2x equals 34. X equals 17.
What?
This part of math makes no sense to me.
I hate
The algebra?
Yeah.
Yeah, it's because
I'm
algebra
so
is
good
not
at
English.
geometry. I can get geometry, but the
Algebra
algebra
is
is
so
so
hard.
That's incorrect.
So we'll
Some
go
of you
over
are
this
embarrassing in algebra
next
too.
year. Okay.
Well, I went over this in Algebra 1, but she just wasn't a good teacher. And I feel so bad for saying that. She's a wonderful person, but she didn't know how to teach.
Okay, well, we'll kind of do this, and you'll get lots of practice in this class too. But you're just trying to get x by itself, and we can go over it if I need to work with you separately, I can do that too, okay?
In Algebra 2 though, right? Because I'm really good at geometry.
Well, you're gonna need to know some algebra to do this class too.
That's
So-
so upsetting. I thought we left that behind. What a terrible. It's not English. It doesn't make sense.
Okay, guys, so here's what I want to do. I want to do another proof. So
George.
here's what the proof looks like. We have time. Given.
Oh, is this the stuff I'm good at?
Yep, this is what you're
Oh,
good
okay.
at. AB is congruent to DC. AB is congruent to DC.
I used to course.
Okay. Okay, this is just a square. So what I'm going to try to prove, we're given that AB is congruent to DC. I want to prove that triangle
AB.
hold on. No. I want to prove that triangle ABD ABD
To ABC.
is congruent to triangle DCA. Okay, so here's what I'm doing. I want to prove that this triangle is congruent to this triangle. So far, so good?
Yeah.
Okay, well, let's try this. So what's my first statement?
What's given?
So AB is congruent to DC. Why?
It's given.
Because it's given. See how easy that first statement and reason is? Okay, so I'm going to just make a tick mark right here, AB and DC. So far, so good? Okay. All right, so then what else can I say? So I want to prove that these triangles are congruent. I want to use my SAS postulate. Okay?
Well, this might not be SAS, but both triangles are 180. Therefore, they are
You mean 90?
equal to, or 90. Yeah. No, because all triangles equal 180, and those are two triangles, right?
Yeah,
So
but
the
then
square
you would
equals
say the sum of the
360.
angles are equal, but that doesn't help us with one of the angles. But what were you saying, Tori?
They're both 90 degrees.
These angles are both 90 because they're right angles.
And that's congruent, right? Or the transitive property.
And technically that should have been given as well. But it's not for some reason. We can just say that it's yeah. This is a terrible proof.
Then let's just not do it and call it a day.
Hey, no. No. Hey.
That's not my spirit.
I'm gonna go to the bathroom. I've learned too much today.
This is just not, yeah, it's just not a good proof.
The only problem is it has a bit of algebra in it, which is from the devil, so.
Okay, shoot. I wish they would have given a better example because this is bad.
But you give a better example.
Okay, so let's just say that this angle is congruent to this angle. Let's say that AB and CD are parallel. Well, you can say that these angles are congruent because of alternate exterior or alternate interior angles are congruent. But that gives us SA, but where's the third side?
Oh, oh my gosh, it's bad.
Okay, so we said that they're given. BAD is congruent to CDA. They're both given. So now we know that this is congruent to this, and this is congruent to this. So where's our third side need to be? To prove that these triangles are congruent, SAS.
Oh, is it on the marked line or the?
Yep, and that side is actually the side of this triangle, and it's the side of this triangle.
So that means
So what can I say next?
they're congruent. Or wait, there's the property, right?
What's congruent?
The angles AB.
No,
or
I'm talking
BAD.
about this side.
Is the angle of BAD and CDA? Or AD and B or NDA? Yeah.
Why can I say that those are congruent? AD is congruent to DA.
Because it's a dotted line and it goes up and down.
Reflexive.
Reflexive. It's
See, that's what I was going
congruent
at.
to itself. Ref, prop.
I defined that property.
Okay? And now we have SAS. So see how it's SAS of this triangle and SAS of this triangle. So now what can we say? If we have SAS, we can now say that the triangles are congruent. ABD is congruent to triangle DCA. Why?
Because of the transitive form, or SAS.
SAS. You're done.
That's it?
That's it.
The other one had like six things.
Yeah.
Cowboys.